All right, so this is lesson 10. This is the last lesson of this week. This lesson we're actually going to split up into two lessons just because the solving of systems of equations is kind of a long lesson here, and then the solving of inequalities is one that we'll start next week. So 10 we're actually going to split up into like a 10A and a 10B. So we're just going to look at systems of equations for this video here. Might be a little long at times, so if you want to skip around to see the different types of ways to solve systems of equations, right, you'll be able to tell based on what example we are on. So the first one, and probably the easiest one here, is solving systems of equations by graphing. But before we take a look at solving by graphing, first let's remind ourselves that a system of linear equations is a set of two or more linear equations that must be solved at the same time. So we're looking at different linear equations. Remember, linear means lines, and their solutions. Now, if we have a system, we're looking for the points that make both of those equations true. And in most cases, it's just going to be 1 point. There is the way, if the line is a line that is graphed on top of itself there, or that is a similar line with the same y-intercept and slope, right? That line could be have an infinite number of solutions, or it could have no solutions if the lines are parallel lines and they do not have the same y-intercept. But that's a little ahead of ourselves here. Taking a look at this first part here, it says graphing is one way the point of intersection can be found for a system involving two equations of straight lines. So consider the system of equations below: y equals x plus 4 and y equals to 2x. Each equation by itself has an infinite number of solutions. Right, so we saw that in the last lesson, that as long as we plug in a number for x, we'll get a y, and we can do that for any number of x's. However, when solving a system of two equations, you are looking for the points that satisfy both equations at the same time. All right, so to solve this system of equations, graph both equations on the same coordinate plane. So once we have them graphed here, right, they go in and they take a look. All we're looking for when we have two linear equations graphed, the solution is the intersection, right? And is the point that it intersects at. So we have this line here and that line there. These two lines intersect right there. We write that as our point. So we go over 4, then up 8. So our solution is the point 4, 8. If they wanted us to break it down into x values, we have x equals to 4, y equals to 8. All right, so that's not too difficult there. If we're taking a look on our calculator and we want to put those in, all right, we start home screen 1, no. Here if we wanted to graph them, all right, so we can put to a graph. And then type in our first one. Remember, if it's f of x, all right, we can just write it as x plus 4. Hit enter. Then we hit tab, do our second equation, which is 2x. Enter. And we're looking for their intersection. So notice how we don't see the intersection here. So what we want to do is change the window. So menu, 4, window. Here, if we just want to do window settings. And then to start off, let's try it as -10, enter, oops, sorry, menu, 4, window settings, -10, +10, but let's make our y min -10 and our y max -10, or sorry, y max +10. Then we see that it crosses right up here. All right, which is again at our point 4, 8. If we wanted to find that cross, all right, we can hit menu. 6, we want to analyze the graph. What are we looking for? 4, an intersection. Then it says lower bound, so we want to go to the left of where it crosses, which is here. You can click. Upper bound, we want to go to the right of where it crosses. Hit enter. And it crosses here, it tells us at 4, 8. which is the same as what we saw on this graph here. So graphing again is going to be one of the easiest ways to tell, as long as our equations are already solved for y and they ask us to find the answer that way. Right? Sometimes they won't allow for a graphic answer there. You'll have to solve it using algebraic ways, and then you can't really do the graph there. All right, so let's look at the sample question here. It says, a cell phone company offers 2 different cell phone plans. Each plan has a different price for a cell phone and different monthly fees. The graph below shows the total costs for the cell phone and monthly fees for both plans. So we have plan P and plan Q. This is how many months, and this is the total cost. So during which month is the cost of both cell phone plans the same? So we're looking for where they're the same or where they intersect, and we're looking for which month. So we just look up here. Oh, look, they cross right there. If we want to find the months, we go down, we see it's month 4, choice C. If they ask for the total cost, that they're the same, right? We would go to the left and see that it was 3, which is $300. So solving by graphing, you're just looking for the intersection of the lines, where they cross. And remember, we write that as an x and a y coordinate, and that would be our solution. Now let's take a look at our second method for solving systems of equations. So each of these next 2 methods that we're going to look at, or 3 methods we're going to look at, are, you can use any of them to solve a system of equations, but we show you all 3 of them so that you can choose which is the easiest method for that specific equation, or system of equations. Some of them will be longer and take more steps, and while you'll get the same answer, you might have a higher chance of making mistakes, or you're just not working as smart and you're working a little bit too hard. All right, so taking a look at this one, we're going to use substitution. So substitution is when we take one value, right, and we put it in for another value here. So here we're doing that, but we're dealing with equations. So these are the 4 steps here that they say are 4 key steps to substitution, is to solve at least one equation for either x or y. So this is important. Solve either one equation for x or y. And this is when we're going to use substitution. If one of the equations is already y equals or x equals, then you know that substitution is the method that you want to use. Then it says substitute the resulting expression for the variable it equals in the other equation, solve the equation, substitute the value of the variable found in step 3 into the original equation to find the value of the other variable. A lot of words there, but we're going to take a look at each one of those steps and what it actually looks like. So what I'm going to do is write down this problem here, right, for sample 2, but then I'm going to flip back to those steps there so we can match which each step goes to in terms of how we go about solving it. So it says, what is the solution to our system? Then it's got negative x plus y equals 40, and y is equal to 5x plus 80. All right, so if we want to solve, we're looking for the x and y value that fits here. So when we take a look at our steps, the first step said solve at least one equation for x or y. So we look at these and we see that this equation here, our second one, is already solved for y. So that's why we're going to use substitution. So then we can move on to step 2. Step 2 says substitute the resulting expression for the variable it equals on the other equation. What that means is we're going to take this 5x plus 80 and substitute it in to our equation negative x plus y equals 40, where the y was, because y equals to this expression, so we can substitute it in there. So the way that looks is I'm going to take the first equation, negative x plus y equals 40. Now I'm going to do step number 2 and substitute it in here. So negative x plus, and I'm going to substitute in 5x plus 80 is equal to 40. Now notice how I put it in parentheses there. I put it in parentheses because sometimes there might be a coefficient in front of that y, or it might be minus y, and you don't want to make a mistake here. Now, because we just have a positive 1 on the outside of these parentheses, we can just kind of remove them, pretend like they're not there, and collect like terms. So here we have negative x plus 5x, which is 4x plus 80 is equal to 40. So now we're going to go through actually and do step 3 here, which is to solve the equation. So now we subtract 80 from both sides, minus 80. 4x is equal to negative 40. Then you get x by itself, divide by 4, divide by 4. And you'll get that x, all right, lose a tiny bit, is equal to negative 10. So now we have our x value. So now we have to go through and do the last step here, which is step 4, which is where we substitute, sorry, you can't see it, substitute the value of the variable found in step 3, right? So here we had step 1, step 2, then step 3, and now step 4, we take this value here, x equal to negative 10, and we substitute it in to either original equation to find the value of the other variable. So if we want to find the value of y, I'm going to substitute it into our equation that has y all alone, because then we'll just have to evaluate the right side of the equation. So step 4, we're going to say y is equal to 5x plus 80. Then we're going to substitute in negative 10 for x and find our value of y. So y is equal to 5 times negative 10 plus 80. And then we work this out, we get y is equal to 5 times negative 10 is negative 50 plus 80. Then y is equal to negative 50 plus 80, which is positive 30. So now we found our x value and our y value, and our final step is to write this as a coordinate with the x first. So it's negative 10, 30, and there we are. So these are the 4 steps that they said to substitution. Remember, we use substitution when one of the equations is solved for y or for x, because then it's easy just to substitute it in. So now let's take a look. So that was the first way that we're going to learn how to solve systems of equations, right? And this is going to take some practice. So even if you don't get it here with these finish line books, right, there are other places that we can be looking for resources, such as Khan Academy for more practice problems if you need them, or message us and we can send you some more examples to go through as well. So a second method used for solving systems of algebraic or equations algebraically is known as elimination. So this is our second method here, elimination. Now, the elimination method is when equations are added or subtracted to eliminate one of the variables, making it possible to solve for the remaining variable. So to solve the system below, you can simply add the 2 equations and the y terms cancel out, so then you can solve for x. So we use elimination when we have coefficients that are the same in front of a variable but opposite signs. So the numbers in front of either x or y are the same number, opposite sign. So one is positive, one is negative. So if we take a look here, the numbers in front of our x's, well, this is a 1 and a 2. So those aren't going to cancel. But if you take a look at our number in front of the y's, we have a positive 1 and a negative 1. So they're the same number, right? But they're the opposite sign. So when we add these equations together, we have 1x plus 2x is 3x. Our y's, positive 1 plus negative 1, cancels out to 0. Then we add the x's, or the constants here. 3 plus 3 is 6. Therefore, x equals 2. So really quickly, we were able to solve that x equals 2. Then, just like with substitution, right, the last step is always going to be to substitute our x value into one of the equations to find the y value. So we took x equals 2, they substituted it into the first equation, found that y was 1, which gave them their answer of 2, 1. So the key here is that our numbers in front of our y's were the same absolute value, right? But they were opposite signs. So when we take a look at the sample problem they gave us here, all right, we'll go through it in the similar method as before. So remember the first step here. First step is going to be to identify if we have a coefficient in front of a variable that is the same number but a different sign. And in this case here, we take a look and see that the coefficient in front of x is 4, and the coefficient in front of this x is -4. So here those numbers are the same, right? But they have opposite signs. So when we add those equations together, it will eliminate. When we look at the y's, they are different numbers, so they won't eliminate, and we'll be able to solve for y. So I'm going to write out our equations again. 4x minus y equals 7. Negative 4x minus 2y equals to 2. And then we're going to add these equations so we can eliminate our x's. So 4x plus negative 4x cancels. Negative y plus negative 2y is negative 3y. 7 plus 2 is 9. Then we solve for y. Divide by negative 3, divide by negative 3. Y is equal to 9 divided by negative 3 is negative 3. So then we can go through here and we take this y equal to negative 3 and substitute it into one of these equations here. So neither of these equations is solved for y, so it doesn't really matter which one we choose. So I'll choose the first one. 4x minus y equals 7. When we substitute in our y, so we have 4x minus negative 3 equals 7. So notice how I put it in parentheses there. It's very important because it'll make it less, you'll have less of a chance of making a mistake here. So here we have 4x, then minus a negative is going to be positive 3 equals 7. Subtract 3 from both sides, minus 3 from both sides. 4x is equal to 7 minus 3 is 4. Divide both sides by 4. 4x equals 1. So now we have an x and y value, but when you take a look at our answers, right, they're written as coordinates. So we need to put it together as a coordinate, 1, comma, negative 3, which here ends up being choice B. All right, then the last one we're going to take a look at, the last way to solve systems of equations is by using multiplication. So what we're doing with multiplication is we're trying to make the problem so that we can use a different method like elimination, but we have to multiply the equations first. So to solve a system of equations, sometimes you must multiply one or both equations by an appropriate number before you add the two equations. So when we look at this example here, right, neither of these equations are solved for one variable, so we're not going to use substitution. If we look at the coefficients, none of them are the same but opposite signs, so we can't just use elimination right away. But what we can do is multiply one of the equations so that it will eliminate with the second equation. So let's see how they did here. So simply adding these equations will not cause either of the x terms or y terms to cancel out. But if you multiply both sides of the first equation by negative 3, then add the equations, the x terms will cancel out. So they're looking here at this 1x plus 2y equals 5. If we multiply this whole equation by negative 3, right, it will change our coefficient in front of the x to negative 3, which will make it cancel with our positive 3x down here. So if you see they wrote it down here, negative 3 times x is negative 3x. Negative 3 times 2y is negative 6y. And then what we do to one side of the equation, we have to do the other side still. So negative 3 times 5 is negative 15. Then at this point, we can use the elimination method because we have the same coefficient in front of both our x's, right? But they have opposite signs, so they'll cancel out. They use the elimination to find y. Y was equal to 3. Then substitution to find x, which is equal to negative 1. And then finally, they wrote their point as a coordinate, -1, 3. So let's take a look at this sample question 4, and we'll go through this one using that method there. So take a look here. We notice that none of the coefficients are the same. And also, so we have to choose which one we want to cancel out. If I multiply the top equation by a number to try and cancel our y's, there's not an easy number I can multiply it by to turn this -4 into a -3. So what we're going to do is make our x's cancel out. So to multiply this 1 and have this cancel out with this 2x here, we have to multiply the whole top equation by -2. So I'll write down our equations. 1x minus 4y equals 9. And we have 2x plus 3y equals -4. So if I multiply this top equation completely by -2, it will make it so our coefficients for the x's will cancel. So I'm going to start by multiplying -2 times -1x is -2x. -2 times -4y is +8y. Then -2 times +9 is equal to -18. Now I'll rewrite the second equation in our system. 2x plus 3y equals -4. So now we can go and combine these two equations. So -2x plus 2x is going to cancel out. So we have no more x's. Then 8y plus 3y is 11y, which is equal to -18 minus 4 is -22. Solving for y, so we divide both sides by 11, divide it by 11, and you'll get that y is equal to -22 divided by 11 is -2. At this point here, we have to substitute y into one of the original equations. Let's use the second equation this time here, just to show you that we can use it. So we have 2x plus 3y is equal to -4. If we substitute in -2 for y, we'll have 2x plus 3 times -2 is equal to -4. So now we simplify the left side. 2x plus -6 is equal to -4. If we want to get rid of this -6 here, we add 6 to both sides. And we get 2x equal to -4 plus 6 is +2. Divide both sides by 2, divide by 2, x is equal to 1. So now we found our x, we found our y. To write our coordinate, we use our x value first, 1, y value second, -2. So if we take a look at this one here, that is choice B. So if the equations don't match, right, and we can't use elimination, we can multiply one of the equations by a number and cause them to eliminate that way. Now let's take a look at, read the last part here. So it says, in most cases, any of these methods for solving a system can be used to find the solution of a system. However, some systems of equations can be solved more easily and efficiently using one method over the other. Graphing is a good method for solving system of equations when both equations in the system are written in slope-intercept form, when the point of intersection on the graph is easily identified, or when an approximate answer is sufficient. Substitution is a good method to use when one or both of the equations in the system are solved for one variable or can easily be solved for one variable. And then elimination is a good method to use when both equations in the system are not easily solved for one variable or when both systems can easily be added or subtracted to eliminate one of the variables. So here, sample question number 5 says, which one of these solutions is most easily solved using substitution? So remember, substitution is where we want either x equals or y equals a number, or an equation, sorry. We look at all of these here, and choice A is the only one that has one of the variables already solved for it there. So y is already equal to a number there. Now, one thing I want to show you how to do is to go back to our calculators And just to check your answers here, remind you how to do this on the calculator. So if we go through here, right, and we work on the calculator, we add a calculator page. If we were picking any system here, so I'll just do the one that we just did here, which was x minus 4y equals 9 and 2x plus 3y equals -4. If we want to solve this on the calculator, we can go about doing menu, all right, and then this is an algebraic problem, so 3 algebra. Then we want to solve a system of linear equations, so 2, solve a system. It says the number of equations, we have 2 equations, right, and we're using x and y. So we type in the first equation on the top, x minus 4y equals 9. Then we write the second equation on the bottom, 2x plus 3y equals to -4. Then if we hit enter, it gives us our answer in x and y form. Now remember that if it's asking you to solve it algebraically and you use your calculator and just give us the answer there, right, it's not going to give you full credit, but it is a great way to check your answer, and even if you're really stuck on a problem, use your answer to work backwards to find a solution. Now this is where we're going to stop for this video here, right, which will be the last one for this week. Right, so when you look at these solving systems of linear inequalities, we can skip this for today. We'll take a look at that on Monday. I just want to go over what questions you should work on in your homework here then. So work on question 1 for sure. It has to do with finding the intersection of the graph there. Question 2 is definitely one that you can work on, right? It has to use with what is the first step of using substitution to solve that problem. So it's not even asking you to completely solve it, just use the first step for substitution. If you want to go through and solve it, go ahead, that'd be great practice. Question 3, skip over for now. You'll look at that next week on Monday. Question 4 here says, which one has the same solution as the system of equations above? So kind of figure out when you're looking at these, what did they do to one of the equations there? Probably to make it so it eliminated, but which one would work? Which one did they do it the right way? Question 5 says, study the system of equations below. Which one is the easiest way to solve it? Question 6 actually has you go through and choose a method for solving it and then solve it. So see which one would be the easiest way here and then try and figure that one out. And then question 7, we want you to skip for today, right? That will have to do with graphing inequalities, which will be the first lesson next week. All right, so if you have questions again, make sure you send us a message on Schoology or in any other way that you have available, email or whatever. And we're really looking forward to hearing from you. Hopefully we can answer some of your questions, and we want to see you do your best, so make sure that you put in your answers for all of your practice quizzes so far, and we will see you when we get back to school. All right.